2016 additional mathematics paper, and again we know this paper has 4 sections: section 1, section 2, and section 3 you do everything. Section 4 you only choose 1 out of 2 questions, and section 4 you know you have statistics and probability. So let's statistics and probability and kinematics. So let's get into it. The formula sheet, and here we go. It says the domain of the function f of x, which is 2x minus 1, is minus 2, minus 1, 0, and 1. And it says determine the range of the function. The range are just the corresponding y values, all right? So we need to find the lowest y value that will satisfy this function for this particular domain, and the highest y value. So generally, the range is going to be between f of the lowest x value in the domain and less than or equal to f of the highest x value in the domain. All right, how do I know that? Because this is a linear function. All right, so the range is just going to be y is going to be between, so y is less than or equal to f of 1 and y is greater than or equal to f of negative 2. Again, I know this because a straight line is linear. All right, as I said, straight line and linear, same thing. F of x is equal to 2x minus 5 from negative 2 to 1 looks something like this. All right, let's say that's when it's negative 2, this is when it's 1. So the lowest y value is going to be right here, which is f of negative 2, and the highest y value is going to be 1. And we know it cuts the y-axis at negative 5. So that's the range. So the range is just y is between, what is f of negative 2? F of negative 2, you put negative 2 here. Negative 2 times 2 is 2 times negative 2 minus 5. That's minus 9. So y is between minus 9 and you put in when x is 1, 2 times 1. 2 times 1 minus 5. I'm getting minus 3, so it actually don't even reach up here so yet. So that's the range. The range is between minus 3 and minus 9. Now it asks us to find the inverse of this function. All right, now to find the inverse, we have to interchange x and y. And so what we're saying is x is equal to 2y minus 5. So we make y the subject by adding 5 to both sides. So we get x plus 5 divided by 2. That's y. If this is y, then this is f inverse of x. So this is going to be f inverse of x. Nice and easy. Now it says, sketch the graphs of f of x and f inverse on the same axis. It says sketch, so you don't need to kill out yourself. All right, you don't have to. It's a sketch. So I'm going to get out my y and my x-axis. All right, and first I'll sketch f of x. Now the domain was, you have to remember the domain. The domain was between negative 2 and 1. Negative 2 and 1, all right? So the corresponding y values were f of negative 2 was negative 9. All right, I know f of negative 1 is going to be negative 7. cuts the y-axis at -5. So this is -5. And then f of 1 is -3. Maybe -3 somewhere here. So this straight line represents f of x. All right, that's f of x. Now we want f inverse of x. F inverse of x, look back at it. F inverse of x is x plus 5/2. So it cuts the y-axis at 5/2. All right, and it have a positive gradient of 1/2. All right, so let's sketch this now. F inverse x plus 5/2 cuts the y-axis at 5/2 and a gradient of 1/2. All right, gradient of 1/2. Gradient of 1/2 cuts the y-axis at 5/2. 5/2 is 2.5. All right. Something like that. All right, I don't like how this look like the gradient is bigger than this gradient, which shouldn't be because the function has a gradient of 2. So let me make this a little more better. I want to show that the gradient is 1/2. So it shouldn't be steeper than this one. So maybe that's better. They intersect somewhere down here, all right? They ask comment on the relationship. So let me just put 5/2 here. And label them that this is f inverse and this is f. Comment on the two. They're a reflection of each other in the line y equal x. All right? They are a reflection of each other in the line y equal to x. All right, so that's it. They're a reflection of each other in the line y equal to x. Now it's saying now to solve the equation 2 to the 2x plus 1 plus 5 times 2 to the x minus 3 equals 0. So to solve this equation, what you are going to do is, first thing, this 2 to the 2x plus 1, you can separate it as 2 to the 2x times 2 to the 1, right? By laws of indices, we can break it out like that. Plus your 5 times 2 to the x minus a 3. Nice. Now this look like we can solve this now, right? Then now, this 2 to the 2x by laws of indices, all right, I don't like these whole heap of lines. I prefer when they give me the space. Now this 2 to the 2x can be written as 2 to the x all square. 2 to the 2x is the same as 2 to the x all square. All right, but then it's being multiplied by 2, so I can just put a 2 on the outside here, plus 5 times 2 to the x minus 3 is equal to 0. Now you may realize that this is like a hidden quadratic. If you call 2 to the xy, this is like you have 2y squared plus 5y minus 3. So call it y, call 2 to the xy. So you have 2y squared plus 5y minus 3, and that equals 0. Clearly. So now that you have a hidden quadratic, you can stay so now and factorize, and you equate it to 0. Now 2y squared can be broken up as 2y multiplied by y, and minus 3 now, it's going to be 3 and 1. Signs are different, and the bigger number goes with the plus, so you put a plus here and a minus here. Let's check if we factorize it right. This time this is that. This time this is 6y minus y, which is plus 5y, so this is correct. So what are we saying then from this? we're getting that y is equal to a half. And from over here, we're getting y equal -3. If you're getting y equal to a half, remember y is 2 to the x. So what we're saying is 2 to the x is equal to a half. 2 to the x equal to a half, and from here, so we're saying 2 to the x is -3. Now 2 to the x can't equal to -3. So what you're gonna write? You're gonna write right here. That's crazy. That's crazy. So you can just put that. That's crazy. Don't be afraid to express yourself. That's crazy. You can't raise a number to a power and get a negative result. All right, so let's write 2 to the x is a half. So if 2 to the x is a half, we can say, all right, if 2 to the x is a half, then 2 to the x is actually equal to a half right now. You can write a half as, we can rewrite a half as 2 to the -1. All right, don't it? We can always rewrite a half as 2 to the -1. So what is x? X is -1. X equal -1. Nice and easy. When you finish, you can always check your solution. Plug in x equal -1. You're going to get 2 times -1 is -2. -2 plus 1. -2 plus 1 is -1. And so you get 2 to the -1 plus 5 times 2 to the -1 minus 3. 2 to the -1 is a half plus 5 times 2 to the -1, which is a half plus 5 over 2, which is 3, and 3 minus 3 is 0. So yes, this is right. Nice and easy. So good. Soft. All right. Now this says given that t is equal to k times p to the, that looks like h over c, make c the subject. I'm going to say this again. Anytime the unknown is in the power, you take logs of both sides. Anytime the unknown is in the power, the first thing you do is take the logarithm of both sides. So what we're saying then is the log of t. Now a lot of people like to write log. All right, I write lg, it doesn't matter. All right, lg, log, doesn't matter. All right, so the log of t is equal to the log of k times p to the h over c. Now we can separate this side now by saying log a b is the log of a plus the log of b. So we can rewrite this now as the log of k minus the log of p raised to the h over c. Yeah, we can definitely do that. And this is the log of t. All right. Now, by laws of logarithm, we can bring down the hc. So I can't bother to write it in another step. So I'm just gonna write in here, bring down the power h over c. By laws of logarithm, we can do that. So now let's go ahead now. We can bring over log k over here to get log t minus log k, which is the log of t over k. So the log of t over k is going to be equal to minus h over c times the log of p. And we want to make c the subject, right? So no issues. To make c the subject from here, depends on which way you want to do it first. First thing I will do is I will multiply both sides by 1 over h. I'll multiply both sides by minus 1 over h, sorry. If I multiply both sides by minus 1 over h, I'm going to get minus 1 over h times the log of t over k is equal to the log of P times 1 over C. All right, nice and easy. So now to make C the subject, you just can do it in 2 steps now. So you divide both sides by log P, and then you flip it. All right, you can just flip it. All right, or what some people just say is cross multiply. You bring the C up here and bring all of this down there. So in general, conclude, you can flip it by saying, bring the C over here and then divide everything into down here. And so what it works out to be is, let me separate it in black. C is actually equal to the log of P divided by all of this right here. Now you can actually bring up the power, you know. You can write it as log of P divided by the log of T over K to the minus 1 over H. That's how you find C. All right, nice and easy, soft. Now let's look at this part of the question now. Now they say the log of x plus 1 plus the log of x minus 1 is equal to 2 log x plus 2. And find what is x. That's what they mean when they say solve the equation. To solve this equation, you need to make x the subject, or find x. So we can connect them by saying log a plus log b is the log of ab. So this works out to be the log of x plus 1 times x minus 1. And that is going to be equal to, we can bring up the power and write it as the log of x plus 2 all square. Yes, you can bring up the power. Write it as x plus 2 all square. Now, if log a is equal to log b, then a must equal b. So what that means then is x plus 1 times x minus 1 is equal to x plus 2 all square. So what they're saying is x plus 1 times x minus 1 is equal to x plus 2 all square. Nice and easy. Now, after you get to this stage now, what you need to do is you need to solve for x. So we can expand out the bracket now. X times x will give us x squared. But this is just a difference of 2 squares. So it's really just x squared minus 1 is equal to expand out x plus 2 all square. That's going to give us first term square plus twice the product of the 2, which is 4x, plus second term square. So we're solving x squared minus 1 is equal to x squared plus 4x plus 4. Now bring over x squared over here. X squared going to cancel with the x squared. All right. All right, let's bring it over to this side. I'm going to bring over everything to this side. X squared over here. X squared is going to cancel. Bring over the minus 1. And so I get 0 is equal to 4x plus 5. And if 0 is equal to 4x plus 5, then x is going to be equal to negative 5 over 4. And that's the solution. X is negative 5 over 4. Nice and easy, soft, with a capital T. And you can always check back your answer. You can put x as minus 5 over 4. All right, and just see if it satisfies that equation. All right, nice and easy. Now this question, part 2. Question 2 now is dealing with discriminants. It says determine the nature of the roots of the quadratic equation. To determine the nature of the roots, the first thing you find is b squared minus 4ac. So b squared is 3 squared minus 4 times 2 times minus 9. So b squared minus 4ac, that is equal to, when you work out the discriminant, let's check it out. 3 squared minus 4 times 2 times minus 9. B squared minus 4 AC, I get 81. So what does that mean? If we get B squared minus 4AC is equal to 81, which is greater than 0, then what that means is that the roots are real and distinct. All right? So we can say the roots, this is describing them now, describing their nature. The roots are real and different. That's what that means. It then goes further now and to say, given that f of x is this, sketch the graph of the quadratic function indicating the minimum value. Now, before I sketch the graph, I want to find the minimum value. The minimum value, yt, the minimum value is yt, or some people like to call it k. Some people like to call it k. The minimum value is 4ac minus b squared over 4a. This is the minimum value, all right? That's how you find the minimum value. So finding the minimum value is actually 4 times minus 9, that's c, times a, which is 2, minus b squared, which is minus 9, over 4 times a, which is 8. Let's work out that now. So we have 4 times minus 9 times 2 minus 9 divided by 8. I'm getting negative 10, negative 81 over 8. I get negative 81 over 8. All right, then you need to find the value of x that occurs with the minimum value, which is xt, and xt is minus b over a. So it's minus 3 over 2. So now we can sketch the function. We just needed the minimum point. All right, so now we can sketch the graph. We know that it's a smile function because a is positive. Once a is positive, it smiles. So we can sketch a quadratic that smiles. All right. And then we can put in the minimum point. The minimum point, as we know it, this is the point when x is negative 3 over 2 and y is negative 81 over 8. Now you might wonder, so you might say, so sir, hold on there, where is the x and y axis? Just relax. Always put the minimum point first. You can sketch the x and y axis after. For example, you know this is negative 3 over 2, right? So the origin, which is at 0, would be to its right, and then negative 81 over 8, that's a negative y value, and so the origin would be somewhere up here. What am I saying? That this is, let me make it a little straighter. So this would be something like the x-axis, all right? Now negative 81 over 8, the x-axis is somewhere over here. You might wonder, how do I know that the x-axis is here? If negative 1.5 is yaso, then negative 1.5 for x-axis must look something like that. Now the only really should know is to draw the y-axis. This is negative 81 over 8. All right, and the graph cuts the y-axis at negative 9. So the y-axis would be somewhere right here. That's the y-axis. because it cuts the y-axis at -9. All right, -9. That's a sketch of it. So the two roots them there, these are the roots. This is your y-axis, this is your x-axis. Nice and easy, soft. Next question, which it look like sequence and series. It's asking us to evaluate the summation, which is evaluating the sum from 1 to 25 of 3 to the minus n. Now I know some persons will be hardworking enough, that's the term we should use, to add up all of them, put in 1, put in 2, put in 3, put in 4, but it's actually going to follow a pattern. Look at this. When you put in 1, 3 to the minus 1, plus when you put in 2, 3 to the minus 2, plus when you put in 3, 3 to the minus 3. You could go ahead and add up everything, you can keep on adding up and 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 keep on adding, but that would take forever. All right. Now it follows a pattern. This is what you're adding. The pattern that it follows, it looks like a geometric progression with a common ratio. To test if it's a geometric progression, then it must follow a common ratio of T2 divided by T1, which must be the same as T3 divided by T2. So check it. So work out what is 3 to the minus 2 over 3 to the minus 1. Check that. 3 to the minus 2 divided by 3 to the minus 1 divided by 3 raised to the minus 1. I get 1 over 3. 3 to the minus 2 over 3 to the minus 1. I get 1 over 3. All right. Now, of course, you're going to get the same if you put in 3 to the minus 3 over 3 to the minus 2. You're going to get the same if you put 3 to the minus 4 over 3 to the minus 3. And so that is indeed the common ratio. So what does that mean? This is a geometric series and we're evaluating the sum. What we're really evaluating is S25. Remember, for a geometric series, the summation formula is A R to the n minus 1, A times R to the n minus 1 over R minus 1. This is a summation, this is a formula for a geometric series, or some people like to use this, A times 1 minus R to the n over 1 minus R. Whichever formula you want to use, that's up to you. All right, generally you use it when it is, this one for when it's divergent and this one when it is convergent, but it doesn't matter in this case, any one of them going to give you the same answer. So you're going to plug in A, which is the first term, as 3 to the minus 1. So it's 3 to the minus 1 times R. R is 1 over 3. Raised to the n is 25. Minus 1 over 1 over R minus 1. R minus 1 is just 1 over 3 minus 1. So we're going to put this in our calculator. Put in our calculator and we're going to get, just working it out now, R is 1 over 3, and that's raised to the 25th power, and it's multiplied by A, which is 3 raised to the minus 1, and it is divided by and I getting minus a half. Negative a half, let me check that again just to make sure. 1 over 3 raised to the 25th minus 1 multiplied by 1 over 3 divided by 1 over 3 minus 1. I get a half. Actually, it's a half. So I get half. So that's the sum. So if you're brave enough, you can actually add 1 over 3 plus 1 over 9 plus 1 over 27 plus 1 over 3 to the minus 14. That's 1 over 81. You can keep on adding those and adding those, adding those. You're going to get a half. Nice and easy, soft. Now part C. Part C says a man invested X dollars in a company in January in 2010, on which he earns quarterly dividends, and at the end of the second and third and fourth quarter in 2011, he earned 100, 115, 130, respectively. Calculate the total dividends on the investment by the end of 2016. Okay. So each year it has 4 dividends because it says quarterly. So he started by investing X, then it's going to increase. So he started by investing, not inventing, investing. He started by investing X dollars, then it increased. So this is the first year, first quarter, then something else, then something else, then something else. That would take care of the first year. This would be 2010. All right. Then he continued now in the second year, it would increase again. All right. Then it go to 100. Then it go to 115. Then it go to 130. All right. So what do I know? What I know is that the sixth term, it follows a sequence that has a common difference of 15. So the common difference is 15. That's what I do know. And I know that the first quarter, second, third, fourth, fifth, the sixth quarter is $100 and the common difference is 15. Now the sixth term of any arithmetic progression, we can call it T6. We know that T6 is equal to A plus n minus 1 times D. All right, X is the amount that he initially invested. It's very important that we find A. All right, so what does that mean? It means that T6, which is 100, is equal to when n is 6 times D. No, 6 minus 1 is 5, so we get 100 is equal to A plus 5 times D. And we know D is 15. 5 times 15 is 5 times 15. I think that's 75, but just to make sure, yes, that's 75. So what this tells us then is that he actually started out by investing $25. All right, he started by investing $25. So $25, then he invested, then it increased by $15. So it's going to go 14x, then 55, then 70, then 85, then bills, then 115, then 130. Cool. So now what do we need to know now? Now that we know how much he started by investing in, you want to calculate the total dividends on the investment by the end of 2016. Now, one thing I noticed, it's going to be 4 dividends in 2010. It's going to be 4 in each year. So it's going to be 4 in 2010. It's going to be 4 more in 2011. It's going to be 4 more in 2012. It's going to be 4 more in 2012, 2013, 4 more. This is 2012, 2012, 2013, 2014, 2015, then 2016. All right, so these are going to be the total amount of dividends. So it's going to be 4, 8, 12, 16, 20, 24, 28. So in total, there are going to be 28 dividends over this period or this time frame. All right, so over these years, it's going to be 28 dividends. So we need to find the sum of the first 28 terms. So first thing we need to remember is that how do we find the sum of 28 terms of an arithmetic progression? Sn is equal to n over 2 into 2a plus n minus 1 times d. That's how we find the sum of an arithmetic progression. So it's 2a plus n minus 1 times d. So what does that mean? You're going to say, sir, what that mean? All you're going to do then is just plug in n as is 28 dividends. That's what we add it up to be. So n is 28. That's what that means. So we're finding S28. So S28 is equal to 28 over 2, which is 14, times 2 times a, which is 2 times a was 25, so 2 times a is 50, plus n minus 1, which is 27, times d, and d is 15. D is 15. All right, that will give us S28. So all of this is going to work out to be 50 plus 27 times 15 multiplied by 14, that's 6,370. 6,370. That's S28. So that's the total sum on the investment by 2016. Now, we didn't have to do it this way. The alternate method, which I'm not going to write out so many, the alternate method would be to actually add up all of them. Once you find that the first, him start by investing 25, you can add up 25 plus 40 plus 55 plus 70 plus 85. Keep increase by 15 until you reach the last term. So you have to keep adding this. Keep on adding and adding and adding till you reach the last term. Keep adding 15 till you reach the 28th term, which I don't know what that would be. And then you add up all of this and you get 6,370. This one would be too long. I'm not going to write out 28 terms. So I'm just showing you the OR method to this question. Nice and easy, soft. And that takes care of question 2. And so complete section 1 of 2016.